Okay, so let's look at this Hess's law again. And in this case, here is the equation that we are looking for, the delta H. 2B, which is boron plus hydrogen, to give borane, B2H6 and gas. So you're supposed to calculate the delta H value for this one. Okay, and so the equations that are given to us are 2 boron, okay, and oxygen to give B2O3, which is gas state, and then borane, which is B2H6, and oxygen, and the delta H values are given to us also in the third equation. We have hydrogen and oxygen to give water, and then we also have water liquid going to water gas. Now, in general, at this point, when you're given equations to work with for Hess's law, most of the time you're probably going to need all the equations, okay? Otherwise, you will not be given those equations. So if you are given 4 equations, make sure you look at all 4 of them before you finalize your answer, okay? All right. So let's look at our strategy, and let me go ahead and number my equations. So 1, 2, 3, 4 equations that I have to work with, okay? And so let's look at how we're going to approach this. First of all, we have boron that we are looking for, and boron is in equation number 1. We have 2 moles of boron that we need, and we have 2 moles of boron in equation 1. So boron is in equation 1 and 2 moles. Okay, so which means that equation 1 we will use as is. Okay, there's no changes to be made, and keep your focus, okay, on the boron first over here, because that's the first equation we are using, because eventually we have oxygen in here and then B2O3, and we're going to have to get rid of some of these things, okay, because that's not in the final equation. So we're going to have to get rid of the oxygen and the B2O3. Okay, so that was our first step that we did. Okay, it's a boron. The second thing that we look at is, of course, the second reactant, which is hydrogen. So hydrogen is 3 moles hydrogen as a reactant, and the hydrogen that we have is in equation number 3, and it is the reactant. Okay, so H2 is in equation 3, but 1 mole. So which means that we will take equation 3 and multiply it by 3. Okay, that's what we need to do. So then we will have 3 moles of hydrogen. Now remember, you multiply the entire equation by 3, not just the hydrogen, but also oxygen and then the water also. Okay, so everything else multiplied, and of course the delta H value. So everything is getting multiplied by 3. Okay, but this is just our strategy right now. All right, and then the next step is our third thing in our equation that we need, and that is B2H6, which is borane, and that is a product. So we look for borane, and borane, B2H6, is in equation 2, and we have 1 mole in equation 2 and 1 mole over here, so which means that we will take the equation number 2 as is, equation 2 as is. Okay, however, not as is, we can't take as is. Why? Because this is B2H6 is the product. Okay, so and 1 mole, but reactant. Okay, so equation 2 reverse. You can take it as is, which means we don't have to multiply it by anything, but we have to reverse it. Okay, so that we have B2H6 as product. Okay, and that's why we need to reverse this. All right, so now at least we have all 3 of our chemicals all accounted for: boron, hydrogen, and B2H6. So now we have the fourth equation that we have to deal with, and this has to do with water. Okay, and so if you look at equation 2, equation 2 will have or has 3H2O. Okay, and so if it has 3H2O in gas form, we need to get rid of that. Okay, because we don't have that anywhere else. Also in equation number 3, we also have water as liquid. And equation 3, we multiplied it by 3 as well. So which means that we will also have 3 of water here. So which means that we can take equation number 4, all right, and multiply it by 3. Okay, so equation 2 has 3H2O and equation 3 has 3H2O liquid. Okay, so we will take equation 4 and multiply it by 3. Okay, and so that is our strategy. All right, I hope it's all clear. You can listen to it again, but I'll just say it quickly. All right, boron is in equation number 1, which is fine, but we need to multiply it by, and it is 2 moles as well. Okay, and it is 2 moles, so take it as is. Hydrogen is in equation number 3, but we have 3, and we need 3, and we only have 1, so therefore we multiply the equation by 3. Borane, which is B2H6 now, that is in the product side, but in equation number 2 it is actually on the reactant side, so we need to reverse this equation. And then finally, our last strategy is for the last equation that's given to us, 4, which is water, liquid going to gas, and we have to multiply by 3 so that we can cancel out all the waters that we will have, okay, in the equation. So now the next step is to actually write out all of these equations, okay, and then we can cancel out and keep whatever it is that we need. It's always a good idea to write all the equations. So I'm going to take it step by step, okay, as is. So first, equation 1 as is, okay, which means that 2 boron plus 3 by 2 oxygen. And if you don't mind, I'm going to go ahead and forego the gases and all that. Otherwise, actually I should write it out solid, because we have water as liquid and gas also. So gas here, okay, and then B2O3 as in gas. We also write the delta H value, okay, and then that's going to be the last column, minus 1273, and this is all in kilojoules. All right, so that's equation number 1. That was our first strategy. Then our second strategy was to take the equation number 3, which was hydrogen, okay, and multiply it by 3. So equation number 3 multiplied by 3. That's our strategy. So 3H2 gas plus, now this is 1.5 half oxygen, so multiply that also by 3. So 3/2 oxygen gas to give us 3H2O liquid, okay, and then we take minus 286 times 3, all right, because that has to be also multiplied by 3. Then our next thing was the B2H6, and the B2H6 borane is in equation 2. So equation 2 we were going to reverse, all right. The mole ratio doesn't change, we still have the 1 mole. So now we're going to reverse this, so which means that we're going to have B2O3 solid plus 3H2O gas to give us B2H6 gas plus 3 oxygen gas. And this is reversed, so which means that our number here is also reversed, so plus 2035. Okay, that is our delta H value. And then our final strategy that we had, and that was for equation number 4, and equation 4 was multiplied by 3 times 3, and we keep it this way. Why? Because we need to cross out the liquid. Okay, water liquid is on the left hand side and water liquid here is on the right hand side. Okay, so we keep it as it is. So 3H2O liquid to give 3H2O gas, and we have 44 plus times 3. Okay, so these are the two manipulations, and the other two kind of remain the same. There we go. At least you don't have to multiply it by 2 or anything, but anyhow. Okay, so that's what it is. Okay, so now what we have to do is add up everything. So when we add up everything, the best thing to do is, of course, first of all, highlight what you need. So you need the boron, you need the hydrogen, and you see it. Okay, so 2 boron, which is not in any other place anywhere else in the equation, and then you need the hydrogen, which is 3H2 gas. All right, and the hydrogen gas is only here and nowhere else. And then your product side was B2H6. Okay, so that is what you need. Everything else should cross out, okay, from there. So let's start with B2O3 because that's the easiest one. Okay, and B2O3, which is gas, and I think I wrote it wrong over here. This is gas also. So B2O3 here will cancel out. Okay, that's gone. The 3 oxygen. Okay, here you have 3 over 2 oxygen, 3 over 2 oxygen. Okay, but then don't forget you also have 3 oxygens over here. All right, so by the time you add up these 2 oxygens here, which makes it 3 moles of oxygen, and then you have the 3 moles of oxygen here, so 3 moles of oxygen on the reactant and 3 moles on the right hand side. Subtract 3 oxygens from both sides and you're left with none. Okay, so then we have water, and we have 3 moles of liquid water, 3 moles of liquid water on either side. Again, subtract 3 moles of liquid water from both sides, subtract 3 moles of water as gas on either side, and everything is crossed out. And so we are left with this equation, which is what we needed. And then you also go ahead and take all of these numbers and you add them together, and when you add them, you should get a delta H value of plus 36 kilojoules. Now I took this a little bit lengthy calculation. Okay, it's a little bit involved, and I was explaining it to you. Okay, so it took me a long time, but usually these equations are a lot faster because you know what you're looking for. And the other thing is that unless you mess up any of the mole quantities, your equation should always come out to be perfect. Okay, so unless you make a mistake in the mole ratios, or if your equation was not balanced, which why shouldn't it be balanced? Because the equations are given to you. So unless anything like that happens, everything should cross out and you should get your final equation. Okay, so there's usually no room for error in all of these. So everything that we were crossing out on the left and the right hand side, they should cross out. Okay, all right.